Good evening. This is a quick video on enthalpy of moist air. So how are we going to get those values? What do they actually mean? So first of all, table A17, that is enthalpy of perfectly dry air. But what we're finishing the semester off with is talking about samples of moist air, like this air right in front of us right here like that. That air has some CO2, some N2, some O2 in it, and it has some water vapor in it, H2O vapor. Obviously we don't see it, and I've been working with you guys to understand that, hey, that water vapor is really significant as far as energy calculations go and energy transfer. So the way the book visualizes it, if you have a sample of moist air, there's the dry stuff, and then a small portion of it is the moist stuff. So all this stuff out here might represent the dry stuff, the nitrogen, oxygen, carbon dioxide, etc. And then there's a little bit of dry stuff. All right, and we're going to start out by working with a sample of pretty warm air. Let's start with a sample of pretty warm air that's 100 degrees Fahrenheit. Okay, Sacramento summer air, and there is some moisture in it. And the amount of moisture, our symbol for it is like a Greek W. Okay, and it tells us how many pound mass vapor there are per pound mass dry air in our sample. Pound mass vapor per pound mass dry air. So the sample that we're going to do is going to have 0.008 pound mass vapor per pound mass dry air. So this is a pound of dry air. The moisture with it is hardly anything, 0.008. Okay, so make sure that you have a psych chart as you're going through this, looking at your psych chart, and you may want to have a ruler as well. That can be really, really helpful. All right, so just a quick reminder on what specific enthalpy is. H, our specific enthalpy. Okay, it is a combination for any substance, is a combination of U, which is the internal energy, the energy due to temperature, the energy within the molecules, plus PV, which we can speak about as the pressure energy. We are not going to use this equation at all for moist air. We're just going to think about what H is, and we're going to go to the psych chart to get values. And that'll be good enough for a start. So don't worry about this equation. This is just a reminder what actually, when we speak about enthalpy, what are we talking about? Okay, so reminder on the psych chart. Let me just draw a skeleton one for you. Okay, for all the properties that we look for on the psych chart, like dry bulb temperature or relative humidity, there are lines or curves where that property is constant. So let's start with temperature. What are those lines? What are those constant? What does that constant line look like? So if we had some sort of temperature like 90 degrees Fahrenheit, it's the vertical lines. Okay, so they're vertical lines going up through the psych chart, and any point on that line, no matter what its moisture level is 90 degrees. Okay, the moisture level lines, those are the horizontal lines. Okay, so if this is some sort of value like 0.009, any point on that line has specific humidity 0.009. Okay, and then we introduce the curves for relative humidity. Okay, there are several in there. Okay, but they almost look like a portion of a parabola. And so if this curve right here was, say, like the 60% curve, that means any point on there has 60% relative humidity, and that would mean that the moisture level for this air is 60% for the maximum moisture level at that temperature. And over here we'd have the same thing. The moisture level in this air is 60% of the maximum level at this temperature. Okay, so when we think about enthalpy, what we want to do is first just be really good at recognizing, hey, are there any sort of lines or curves that represent constant enthalpy? So taking a look again at your psych chart. So here's our psych chart, and I'll hold it a little bit closer. You see up here specific enthalpy, okay? Or actually it just says enthalpy, BTUs per pound mass dry air. And there are numbers there that go in increments of 5. So starting down here, we've got 15, and then 20, 25, 30. And there are lines that go across, and then those lines cut through the psych chart and are very useful for identifying specific enthalpy. So I'm going to take a look at, for example, this 30 line. This 30 line goes all the way through the psych chart, and if you look down at the bottom, there's a 30 over there like that. So any moist air that's on this line has 30 BTUs per pound mass dry air. And you can understand that when you think about what's going on if we follow that line. Okay, if I'm down here, I'm really, really hot air with not much moisture. Okay, and then if I follow this line up, temperature is decreasing. That should mean less energy, but at the same time, moisture level is increasing, and water vapor has a lot of energy. A way to think about it is that if you want to add water vapor to air, well, you've got to ordinarily take liquid water and make it into vapor, and it takes energy to take liquid water and make it into vapor. So as we follow up this line, we have less temperature, and therefore you would think lower enthalpy, but we have more water vapor and higher enthalpy. Okay, the next thing is thinking about, hey, how precise do we need to be if we have some sort of dot on that chart and we get its enthalpy? If you look at these solid lines, they go in units of 5 BTUs per pound mass. So if I'm somewhere in between two of these lines, I might say, I just need to get some idea where it is, say relative to the upper line and lower line, 30 and 35. But we want you to be more precise than that, and it's not that hard to do, because even though lines in units of 1 increment don't go through the chart, we can easily either visualize or add them. So I'm going to take a look, just for kicks, at the 21 line. So this is 20 right here, and there's a 21 dash right there. If I go down to the bottom, there's 20, and there's that dash right there is 21. So if I were looking at the psych chart, I could try to visualize that line, or if I really want to be precise, I can lay down a ruler and actually draw that to help myself out. So you just take, I'll show you in just a second, you just take your ruler and line it up with the 20 on either side, 21 on either side, 20 above, and 20 below. Line that up, take a moment to get it right, and then you could actually draw the line. I'll hold it up for you. Okay, so there we go. So I've got a 20 line, a 25 line, and actually I have a 21 line. And so if I have a point there, I can be pretty precise about it. Okay, so let's go ahead and get the enthalpy of that air that I was talking about. It's 100 degrees Fahrenheit, 0.008 specific humidity. What you're just going to do is first follow up the 100-degree line. So follow up the 100-degree line, and then go across from the 0.008 and plot your point. So go ahead and do that. You can do it lightly in pencil. When you take test 3, if you want to bring a clean psych chart in so that you can mark it up as you read various points, that's just fine. Okay. I made a mistake there, so I'm going to have an extraneous dot on my graph. But don't stress about it. Okay, so here we go. That bottom of the 2 dots, that's at 100 and 0.08, and I want to figure out what its specific enthalpy is. So for starters, the bold lines, it's between the 30 and 35 line. It looks like about halfway in between, so we might say, hey, I'm just going to call it 32.2 or something like that, or maybe it's a little bit closer to 30 than 35. I'm going to call it 33. But we want you to visualize those whole number lines in there and do a better job of estimating that. So what I'm going to do is I'm going to draw in the 32 line, and I encourage you to do so as well. So I'm going to take that, and I'm lining up my ruler with the 32 on one side and 32 on the other. Taking my time, making sure I got it right. Once I do, I'm going to take my line across, and let's take a look at what we got. So there we go. Again, we're ignoring the upper dot. That's my 32 line. Clearly, it's above 32. But what about 33? Should I call it 33? It's a little bit higher than 33, lower 33. Well, what we're expected traditionally to do is be able to either lay down a ruler and look at it relative to a ruler, or even draw that line in. So you don't need, once again, you don't need to draw the line, but laying down the ruler is a helpful thing to do. Okay, so that second line that's close there is the 33 line, and strictly speaking, it's just a little bit below. So we would want to call it something like 32.8, specific enthalpy 32.8. Now look, that one's really close. If you were to call that 33, I'd probably call it good. But on the other hand, if you said something like 33.3 or 33.4, I know you didn't lay down that line and take a look at it. So, because clearly it's not above that line, it's below the line. Okay, let's just do one more and think about it. Let's go ahead and do some cooler air, 75 degrees Fahrenheit, and specific humidity, 0.014. So just a prediction, that's cooler air. That is moving over to the left over here like this. Enthalpy is like energy. Temperature relates to energy. So cooler air, we would think would have a lower enthalpy, but we're not sure because at the same time this has specific enthalpy, 0.014. It's got moisture in it. So go ahead and take your time and plot that point, and I'll get it up there myself. 75 degrees Fahrenheit. I'm going up, 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 up till I get to the 0.014 line. Okay, and so there it is. There's the 75 degree line going up, and the 0.014 line over there, and there's that point right there. Okay, it is just a little bit above that 33 line that I just drew. Okay, now is it above or below the 34 line? Well, I think you can see that pretty clearly just by looking at it. The 34 line, there's that 35 over here, and there's the 34 line. And if you thought about that 34 line going through, it looks to me like it's going to be in between 33 and 34. Okay, so we want you to estimate 1 decimal point beyond the lines or curves that are given. So are we going to do 33.1 or are we going to do 33.9? Where is it going to be? I think you can see it just by looking, but I'm going to draw on the 34 line just to be sure. So I'll take my time and I'll draw on the 34 line. Once again, if you practice this, eventually you'll find that you're not drawing in the lines. You're actually just holding a ruler there to help you out. Okay, so there we go. So now I got that point again, and the that point's between the 33 and 34 line. It looks to me like it's closer to the 33, and in fact, in reality, if you go through the theoretical calculations, it is closer to 33, and it's about 33 BTUs per pound mass dry air. All right, that's a starter on specific enthalpy. Make sure you keep working your way through homework number 11. There's one last property, the last property of the year, which is the dew point, and I'll post a short video about that soon. Please email me if you have any questions.